right, so welcome back. We're going to jump into the quotient rule now. So we've got the product rule, we've got the negative exponent rule. So now they're needed to help with the quotient rule. So the quotient rule basically says that if you're dividing two things with exponents, then instead of adding them, you got it, we're going to subtract them. So pretty quick with the process, but obviously with the negative exponents, we want to be a little bit careful. And typically they like to only have answers with positive exponents, so that's something to be careful about as well. All right, so this first one, 5 to the 17th power over 5 to the 6th power, nothing, weird about that one. We could just flat out subtract. So 17 minus 6, which is 5 to the 11th. Done. Nothing fancy. Now, with this one, you do have options. Because you have a negative exponents in there, you can choose to get rid of those first if you don't like them. But we have this new rule. We can apply this rule first if we want to as well. Either way you slice it, you want to be really careful with those negatives. So let's do it both ways, and just to see that it comes out to be the same answer. So some of you might say, well, I don't like the negatives. I'm going to get rid of those first. So I'm going to do my little swap with these. And so the negative, the 3 to the negative 2 is going to go up to the top and become a positive 2. 3 to the negative 5 in the top goes down to the bottom and becomes a positive 5. All right, so that's step one. But now we do have to apply our new rule. So we want to subtract those exponents. So this is going to be equal to 3 to the 2 minus 5, which is equal to, I'll go down, 3 to the negative 3. 2 minus 5 is negative 3. But because the question wants only answers with positive exponents, we got to go one more step. So again, think of this as being in the top, so we got to go down to the bottom. And so this is going to become 1 over 3 to the third power. So that's one way you could have done it. Now, some of you say, well, I want to use the quotient rule first. There's nothing wrong with that. So if we use the quotient rule first, then we got to be careful. So it's the top exponent minus the bottom one. So you're going to have a negative 5 minus a negative 2. Well, negative 5 minus negative 2, well, this is going to double negative, so that's really a plus. So what's negative 5 plus 2? Yeah. 3 to the negative 3 again. So you get the same answer either way. So that's what's nice about these processes, is sometimes you do have more than one way to get to the same result. So, okay, one last example on this part, a little bit more involved. So we got tens for our bases. We got an exponent of 3, exponent of negative 4, positive 2, positive 5. So how do you want to start this one? Now you don't always have to get rid of the negatives first. But if you wanted to, the only thing that's going to move would be this 10 to the negative 4. All these other ones are positive, so they're not going anywhere. They're going to stay right where they are. So be careful of that. But if you want, you can use the product rule first. So let's combine across on the top and the bottom and see what we get. So the top, you're going to have to add those exponents. So you got 3 plus negative 4. And on the bottom, you got 2 plus 5. So that better be 10 to the negative 1 over 10 to the 7. Right? So now we're just going to get rid of that negative based off of the instructions. So the only thing that's going to move is this is going to move down to the bottom. So because we're getting rid of everything, that's going to just be left with a 1. So now you got 10 to the first times 10 to the 7th. So that's going to be 1 over 10 to the 8th. And that would be your answer. So not terrible, but just be careful. Some people get really gung-ho and they want to move everything, even the positive ones. Don't move the positive exponent ones. Those always stay in where they are. So, okay. Now, the next rule or property is the zero exponent rule. And this one is just kind of a silly one, but it's important as well, though. If a is a non-zero real number, then a to the 0 equals 1. So no matter what base you have, as long as it's not 0, if you raise it to the 0 power, you get 1. The big question is why? Why would that happen? Well, let's see if we can work backwards. If I'm starting with 1, I can write that any way I want. So I'm going to pick a random base. Let's pick 4. Let's pick 4 to the 20th power. But if I want it to equal 1, then I better put the same thing on the bottom, right? 4 to the 20th over 4 to the 20th, that's going to be equal to 1. So that's true, right? But now, what's our quotient rule say? We can subtract those exponents. So down here, we would be able to rewrite this as 4 to the 20 minus 20 power. But 20 minus 20 is 0. So no matter what base I pick, as long as it's not 0, I can always do something like this and show that that base to the 0 power equals 1. So it's just a nice little property. Okay, now the last set of rules is going to get into the power rule. Maybe I should make you see it. So yeah, we got the power rule. Now there's 3 layers to this, which seems, but it's not. So the first one is involving parentheses, and it's got basically a power on the inside, and it's raised to a power on the outside of the parentheses. When that happens, we can just flat out multiply those exponents together. So it's not quite the same as the product rule. The product rule has 2 bases and 2 exponents. So, and that's when you add, but in this one, you can see it's definitely different. There's only 1 base, and then there's 2 exponents. And one's on the inside of the parentheses and one's on the outside. So that's when you multiply. So be really careful with those 2 rules. The next 2 are kind of looking at products raised to a power and quotients raised to a power. Essentially what you're doing is you're going to distribute that exponent onto each piece inside. So it's distributed to the top and it's distributed to the bottom. And that's it. So that's how that power rule works. So it's kind of like distributing. All right, so let's see what it looks like for this first one. So we have a product and it's raised to a power. So everything inside gets that exponent. So the 3 gets the exponent and the x gets the exponent. Now, that's okay for an answer, but when the exponents are small like this, I would say go the extra step and just simplify that. So 3 to the second we know is 9. So this should be 9x squared. Okay. What about this one? Now we're applying the first rule of the power rule, and we're going to have an exponent on the inside and an exponent on the outside. So we got to distribute it and multiply it in. So this should be z to the negative 6 times z to the second. So that's step 1. Multiply those exponents together. So think parentheses and multiplication go together. All right. Now, though, we have 2 bases, 2 exponents. The product rule says we add. So negative 6 and a positive 2 better be a negative 4. But positive exponents again, so we got to move it down. So 1 over z to the 4th. Not bad, right? Okay, what about something like this? 1/5 to the negative 3rd power. Well, first step is get rid of those parentheses. So we got to distribute that exponent to the top and the bottom. So we're going to have 1 to the negative 3, 5 to the negative 3. And we don't like negatives, so let's do a little swappity swap. So that's going to give you 5 to the positive 3 over 1 to the positive 3. So 125 over 1, which is 125. All right. Now the last one is really fun. So now we got some numbers that are just kind of lingering in there just to be funny. And then we got our exponent stuff, and then we got parentheses, and we got more exponents. So, okay. Well, let's see if we can apply the first layer of the power rule. So remember, the first layer of the power rule says if there's something on the inside and an exponent on the outside, we can kind of distribute it in. So in this case here, we can distribute that exponent onto the 6 and onto this power of 10. So then same thing on the bottom. So we're going to get 6 to the second times 10 to the what? We're going to multiply those, so that's going to be a negative 4. On the bottom, same thing. So the 2 gets distributed to the 3 and to the 5, so that is going to change it to a 10. All right, so that gets rid of the parentheses. Now we should do a little bit of simplifying with that. So let's do that real quick. So 36 and 9. And so now, how do we go from here? Well, you actually just have to kind of separate it out. So we got the 36 and the 9 go together. So we can divide those flat out, which gives you a positive 4. But now the powers of 10, how do we combine those? Because we're dividing, what do you do with the exponents? You got to subtract, right? So negative 4 minus 10. Okay. Now, we got to just combine those together. Now that doesn't look too terrible, and it's actually going to build into the next section quite well, but it's not quite what the answer's looking for. They still want those positive exponents. So in this case, we're going to have to move that negative exponent to the bottom. So, but the 4 doesn't have one, so that stays in the top. Think of this whole thing as being over 1. So just this piece is going to go down to the bottom. The 4 stays on top, 10 to the 14th on the bottom. Okay, so now, but you only have to do this when it asks for it. If it says write your answer with positive exponents, then make sure your answer has positive exponents. Now that I've just said that, I want you to totally disregard it when you're talking about scientific notation. Scientific notation is a spin-off of this, but you don't have that requirement of always having positive exponents. So let's take a look. And actually, I'm going to take a look in the next video. Psych.